When you picture a high-risk radiation environment, you expect to see something like this: nuclear technicians clad in specialized suits, surrounded by strict safety protocols. You probably do not picture a flight attendant serving coffee at 35,000 feet. Yet, this chart comparing occupational health data reveals a strange paradox. The calculated risk of radiation-induced cancer for a commercial flight crew actually surpasses the risk faced by many protected nuclear technologists. The nuclear industry operates on a strict baseline of safety. Workers have hard dose limits, and their cumulative exposure is meticulously tracked by personal dosimeters, like the one clipped right here. Commercial flight crews, however, operate almost entirely outside of those standard radiation protocols. There is zero mandatory individual exposure tracking for the people working on your flight.
To understand why a cabin holds more risk than a power plant, we must look up and examine the mechanics of our atmosphere. Earth is under constant bombardment from primary galactic cosmic rays. These are highly energetic protons and atomic nuclei traveling inward from deep space. Down at sea level, we rarely notice this. Earth's lower atmosphere is incredibly dense, and that thick layer of gas acts as a massive physical shield, neutralizing those incoming rays long before they reach us. But a commercial airliner ascends to a cruising altitude of 30,000 to 40,000 feet. That puts the plane above the thickest, most protective layers of our atmospheric shield. Up there, the air thins out dramatically, leaving the aircraft directly exposed to the cosmic radiation stream. By leaving the lower atmosphere, humans trade the physical protection of dense air for a highly radioactive environment. When those primary cosmic rays hit the remaining sparse molecules in the upper atmosphere, they shatter. The collision creates a shower of secondary particles, primarily heavy neutrons and muons. These secondary particles carry immense kinetic energy. They pass cleanly through the aluminum hull of the aircraft and directly through the biological tissue of everyone inside. The intensity of this invisible particle shower fluctuates. It spikes drastically when planes fly at higher latitudes near the poles, climb to taller altitudes, or fly during active solar flares. To put a number on it, taking a single long-haul flight can expose a person to the exact same radiation dose as receiving a medical chest X-ray. For a passenger taking a vacation once a year, that dose is negligible, but for a flight attendant or pilot logging 1,000 hours in the air annually, the risk model changes completely. The commercial aircraft cabin functions as a low-dose radiation chamber, slowly accumulating cellular damage over the course of a career. This brings us back to the crews spending decades operating in this unshielded, high-altitude environment. This graph maps out the epidemiological data. When compared against the general population, studies consistently show that airline personnel suffer from significantly elevated rates of breast cancer, melanoma, and other radiation-sensitive malignancies. These cancers are the biological consequence of absorbing a continuous, untracked lifetime dose of ionizing radiation. Because the aviation sector failed to monitor this invisible exposure, that institutional blind spot has resulted in immeasurable human cost. Unlike the nuclear industry, which builds its entire operational workflow around mitigating radiation, international regulators have largely treated cosmic radiation in aviation as an afterthought. Occupational health experts are now outlining a clear framework to fix this. The first step is mandatory dose tracking, deploying personal dosimeters so individual exposure is actually recorded. The second step is refined flight scheduling. Airlines need to actively adjust their duty rosters to ensure no single crew member exceeds a safe cumulative dose threshold over a given year. Third, the industry must implement specialized long-term health screenings designed specifically to catch radiation-induced illnesses early. The push for harmonized regulations isn't coming from the top down. It's actively driven by flight crews and unions themselves, demanding standard occupational safety. Protecting the people who facilitate global travel requires acknowledging a simple physical reality. Operating in the upper atmosphere requires the exact same regulatory caution as working inside a nuclear reactor.